This lesson is for Advanced Algebra, Lesson 5.3 on solving systems using substitution. It's real important for students to remember what a system is. It's just a bracket with multiple variables or multiple equations that they're solving. And when you do that, students, make sure that you know that you're solving for all the variables. So don't just solve for one variable and quit. Make sure you list all the different variables that are in the system and give an answer for each. When you're working with a system and asked to solve, one of the things you want to look for is variables that are single, variables that are all alone. When some of the equations are equal to a single letter, substitute them into the other equation. After you do that, there should only be one variable left to solve for. So as you look at this system, I know what x is and I know what y is. Those are both given in terms of z. So if I use those as substituting elements in the first equation, I'll only have z to solve for. When you're solving, you can only solve for one variable at a time, so that's a good method to use. So what I'm going to do is take 4z here. I'm going to plug that in for x. So I'm going to replace x with what x is equal to. I'm going to do the same thing with y. I'm going to replace y in this equation with what it's equal to. I'm going to leave that z alone, and I'm going to leave the 4216 alone. After I'm done substituting, I'll get a brand new equation. So instead of x, I'm going to rewrite that equation as 4z. Instead of y, I'm going to replace that with 3z. And then the rest of the equation just stays the same. Z equals 4216. Now as you look at your new equation, there's only one variable left to solve. Those are all like terms, so I'm going to go ahead and add those together. 4z plus 3z plus 1 more z makes 8z altogether. Keep in mind that you're not changing this to z squared or z cubed because we're not multiplying. When you're adding, you just add the coefficients in front. Now to get z alone, I would divide both sides by 8. And when I divide both sides by 8, I get 527 for z. This is the spot where I want to remind kids, don't forget to solve for all the variables. We have z, but we still need to find x and y. If I have the z value, I'm going to go ahead and plug that in these two locations to get my x and my y. So I take 4 times 527, and that'll tell me my x value. So that ends up being 2108. If I take 3 times 527, I'll get the y value, and that's 1581. So now I have all the variables listed. I've solved that system. When you're working with a system and you do substitution, sometimes you will need parentheses. I notice here that y is a single variable, so I can use that to substitute in to the top equation. So I'm going to put this in parentheses, and I'm going to substitute that in for y in that top equation. So I'm going to rewrite that top equation as 6x plus 12. Then in place of the y, I'm going to put in this entire expression, 2 minus 10x. Now you'll notice that the only variable left is the variable x. I can solve for x now. Before I can do that, I need to go ahead and do the distributive property. So I'm going to go ahead and distribute the 12 to all of the pieces on the inside. That will get rid of the parentheses. So now I've got 6x plus 24 minus 120x, and the parentheses are now gone. I do have some like terms here that can be combined. 6x minus 120x is going to be negative 114x. And now the x is going to stay put. The negative 114 and the 24 both need to go to the other side. 24 is further away, so I'm going to subtract 24 from both sides. The negative 114 drops down. 5 minus 24 is negative 19. Now I'm going to divide on both sides by negative 114. And I'll get an answer for x. So x ends up being 1/6 here, and a fraction answer is going to be better for students to utilize. Now that I have my x, I'm going to plug that back in either equation to solve for y. If I plug it into the second equation, I'm going to get 2 minus 10 times a sixth. Keep in mind that that 1/6 is in parentheses. So now I'm going to do 10 times 1/6. I get 10 over 6. 10 over 6 reduces, well actually I want to get a common denominator here so that I can subtract. So to get the 2 to have a 6 on the bottom, I would multiply the top and the bottom by 6 each. So I end up with a 12 over 6. 12 minus 10 on the top is 2. 6 on the bottom stays, so I end up with y is 1/3. So I've got my x and I've got my y. So just watch out on that one because the y value was an entire expression. When I substituted it in, I needed to use parentheses. So one other type of substitution that I want students to look at today, and that is when they have two equations that are equal to the same thing. So I've got single variables again, but they're both the same single variable. So what I can do is set them equal to each other. Since the first equation is equal to y and so is the second, that means 4 minus 2x is equal to the second equation, which is 1/2 8x minus 12. So I set the two equations equal to each other. Now I'm going to simply solve for x because that's my only variable. I'm going to go ahead and use the distributive property here to eliminate some parentheses. And when I do that, I get 4x minus 6. The x's need to get together first. There is no right or wrong here on how to get the x's together. You could either subtract 4x from both sides or add positive 2x to both sides. I prefer positive values, so I'm going to add 2x to both sides. I don't need to add it to the 4 or the 6 because those are not like terms. Now I get 6x minus 6. Now the x is going to stay put, and the negative 6 and the 6 need to move to the other side. So I'm going to add 6 to both sides, and then I'm going to divide by 6. Reduce that fraction to lowest terms. If you cut them both in half, since they're both even, I get 5/3 for x. So now let's go ahead and find the y value, because remember you have two variables you have to deal with. For the y value, I can plug it into the x value into either equation. I'm going to plug it into the top one because it doesn't have any parentheses for me to deal with. So I'm going to multiply by that 5/3. When I multiply fractions, just remember that it's 2 over 1. So I'm going to end up with 10/3 there. Again, I need to come up with common denominator. So if I want the 4 to have a 3 on the bottom, I would simply multiply it by 3 over 3. So I end up with 12 over 3 minus 10 over 3. So I end up with 2/3 for the y value. Just a little bit of vocabulary here for students. When a system has one or more solutions, it's considered a consistent system. There will be some situations that students will encounter where the system doesn't have a solution, and we call that an inconsistent system. If students want further information about that, they can see example 3 on page 316. We're going to do one more example here with students, and hopefully that'll help them learn the difference between consistent and inconsistent. I'm going to move this over because it's not where I want it to be. And let's go ahead and solve. I see that I've got a single variable, so I'm going to substitute this expression in for x into that equation. So I'm going to rewrite that bottom equation as 2 times 4 minus 3y plus 6y equals -2. I can go ahead and distribute here. 2 times 4 is 8. 2 times -3 is -6y plus 6y. Right away I can see that there's a concern here. -6y plus positive 6y is going to go away. So on this side I end up with an 8, and on the other side I have a -2. Clearly those numbers are not equal to each other. So what I can say then is this is an inconsistent system, and therefore it has no solution. So if you think about that graphically, these lines will never cross. The notes are officially finished now, but there are a few more questions talked about here in the video for students. Some of them are related to the homework. So I'd like students to try problems 8, 9, and 10 right now on their own, and then those answers will be revealed here in the video. So as you look at number 8, if you plug the y value into the lower equation, you'll end up with x times 5x equals 500. X times x is x squared. Divide both sides by 5. Take the square root of both sides and you get positive and negative 10. If you plug positive and negative 10 back into the first equation, 5 times 10 is positive 50. 5 times negative 10 is negative 50. So you end up with 4 solutions there. A positive negative 10 and a positive negative 50. In question number 9, when you solve that system, I plugged the top equation into the the bottom equation into the first. So I took this equation and plugged it in right there for x, did the distributive property, and when I simplified, I ended up getting a non-true statement. 0 is not equal to negative 8/3 plus 3. So this was another example of an inconsistent system with no solution. When I did number 10, looks like I plugged this portion in for y into the second equation, did the distributive property there, and again I ended up with, this time, a true statement but no variable. So I wasn't able to solve for x here. I got a statement that was true, 4 equals 4. What that means is this is a consistent system, but it has an infinite number of solutions. I wasn't able to solve for x, so that means every x and every y are shared in this system. So that means these two equations are actually identical to each other. So it's the same equation twice. So this is a consistent system. They share every solution. There's an infinite number of solutions.